Right then, let's have a look at this question all about temperature changes. We have got two metal cubes, X and Y, and they have different lengths. One of them gains energy Q, and its temperature rises by delta T. The other gains thermal energy 2Q, and we're asked to compare the energy rises of the two. Okay, so to do this, we've got to think about that cube first. Okay, anytime you see a cube, it's usually going to be involving the dimensions of the cube and also the fact that they're the same material, and that will come in twice to this question. Let's have a look. First thing to remember is that the volume of X is going to be L cubed because we have a cube with sides which are all equal to L. We also know that the volume of Y is going to be 2L cubed, which becomes 8L cubed, and you notice there that we've got 8 times the volume. Now, what does that mean for our question here? It means that we can compare the masses of the two, because the mass of Y, assuming it's the same material, is going to be 8 times the mass of X. Anything with the same material has the same density. So that's that first time this idea of the same material comes in. Same material, same density. Therefore, their masses are going to be different by a factor of 8. Why is that important? Well, to calculate our temperature rise, we're going to use our equation Q equal to mc delta T. Or in other words, for delta T for X, delta Tx is simply the temperature rise in X, and that's the ratio of Q, the input energy, to its mass times its specific heat capacity. We're going to do exactly the same rearrangement for temperature Y. So that would be delta Ty is equal to the heat input into Y divided by the mass times the specific heat capacity. So let's stick that up there. Delta Ty, well, in this case, the energy input is 2Q because it gets an extra amount of energy in, as according to the question, divided by the mass of Y and times it by C. And we notice there that we've got the same factors Q over mx times C in that second version of the equation. Now remember here, the specific heat capacity of the two materials is the same because they are the same material. And therefore, we can resubstitute in and we find that our temperature rises are different by a factor of 4. In other words, we have answer